Okay. Bismillahirrahmanirrahim. So today we will discuss about the criticality analysis and automated fire flow analysis. But before going into it, I want to show you something about the profiling in WaterGEM. For example, if you want to know about the hydraulic grade of line or the energy grade line of specific junctions or specific pipes, then you can easily find these profiles in WaterGEM. So in order to find the profile of each node, so you can open the profile by going to the view tab and then click on the profile. After opening the profile, you can just dock into anywhere you want, or by placing anywhere, just create a new profile, then select a specific nodes where for which you want to draw a profile. So you can draw a profile for different things like head loss, pressure, depending upon your demand. So I want basically for these nodes to draw the hydraulic grade line, or to show the profile of profile. So these are basically the points which are selected from a drawing. So after selecting these point junctions or pipes, you can open the profile, and here you can draw a profile for a hydraulic grade, for a demand, for a pressure, and similarly for the fire flow. So these are the different parameters. So depending upon your demand, you can change these parameters. So I want to check the hydraulic grade line of these pipes and junctions. So click on OK. So it will show you the hydraulic grade and the elevation profile of these junctions. So the blue lines basically shows the hydraulic grade line, and the orange line shows basically the elevations of these junctions. So as we studied in a theory that by going from the high level to a low level due to the friction and minor losses, basically in these example we are not considering the minor losses. I will show you that how to assign these minor losses to these pipes. Here the losses are occurring only due to the friction. So you can observe that by going from a tank to the each respective junctions, the hydraulic grade line HGL is basically the head loss is basically decreasing the hydraulic grade line by point to point, and these are basically the elevation of ground. So you can you can manage the different properties of this profile. You can manage the title, this title of hydraulic grade line. You can change this. For example, I want this HGL. So you can easily change this that legend of the of your profile for respective HGL or the elevation. You can also change for this as well. You can clone this as well. These are the different properties. Okay, I want to show you one by one. You can change the different types of graphs depending upon your demand. So explore these different types of graphs by yourselves. It will take a time if I go to one by one to each profile type. So basically, if you find any difficulty, then you can discuss with me. You can also change the border of your profile, and you can also change the boundaries colors. I will change this. For example, I will change it to the orange. So the border color you can easily change of this profile. Similarly, you can change this color as well. Basically it is lower, so the color of this is change. So by changing different type of these parameters, you can get the different types of results. You can visible the borders, change the color of that as well. I think so. Basically, this is the border. You can change the different image bevel and its border color. You can also play around with these bottom axis. You can change the scales of these bottom and the left axis. You can also change the title of the these bottom axis. For example, the distance that the title of the bottom axis you can change from here. You can change the font and fill, etc. You can change the text, that type the text. I will change it the color. For example, this. So you can change the axis, color of axis. You can change the color of text. So basically, these are the different properties. I will not most of the time on this. So please go through these different type of properties. You can also print this profile based on your demand, and you can also check the different properties of your specific junctions or pipes you have selected in the data form and the X spreadsheet form. You can play around with these properties as well and you can also export it to the PDF, TIFF, GIF, PNG, and GPG format. You can also add the legend to your profile. So here I add the legend. Similarly, you can also that animations like this. I don't know about this way. Basically, it's showing the animation. By basically, I think it's showing the elevation of each point for all the nodes. You can also do the theme. You can also change the theme of your profile. So you can change this as well. So these are the different properties of this graph. You can check around by yourself, and if you have any question, then you can ask. So I will not spend much of the time. Oh, I think it crashes. Okay. Okay. The other thing I want to show you that, for example, what's happening? Okay. For example, if you want to create alerts for yourself, for example, you have 1,000 of nodes in your model or 1,000 of pipes, and you want to by going to each nodes and by checking the each pipe diameter, so you can easily create your alerts. For example, if you want to check that, for example, in some node you want to check that the pressure at that node should be less than that. If the pressure at node, for example, is less than the 50 psi, then alert me that check this node and check the pipe diameters connected to these and how to correct this as well. So basically, I want to here I want to create an alert. For example, it's a critical situation, and I want to, for example, for a junction, and include for I want to create an alert for all the elements in this model, and I want to check, for example, the pressure. And I want to give me the after running a simulation, the model or the software alert me that these point, for example, I'm giving the values where the junctions where the value is less than 50 psi, it gives me alert. So if I run the model, so it will give me the alert that the pressure less than or equal to the threshold 50 psi is raised. So basically, by doing this, you can create your different types of alerts for yourself, just for your easiness. I want to show you something that the minor losses. Okay, okay. In this pipe, you know that we have also added a bend. So incorporate the minor loss due to bend. You can do that easily from the property of that of your respective pipe. So these are the library where the coefficients of for the minor losses are available. So based on your bend, you can easily give the value for the minor losses and use this in the model to in order to calculate the pressure and the hydraulic rate at each junction. So I will take this as a 60-degree bend. So it is not that much have effect on the simulation. Okay, other thing I want to show you that, for example, the related the summary of the model, the selection set. Okay, for example, if you want to create a selection set, for example, if you want to make automated fire flow analysis for specific junctions, because it is not important to do a fire flow analysis for all the junction in the model. We mostly do fire flow analysis for a specific junctions in a model, like the junctions are near to the factory or industries or schools, something like that, depending upon the standards. So mostly for these situations, the specific junctions are selected, and based on these selection set, we do a fire flow analysis for these junctions. For example, I want to create a selection. So to create a selection, select in drawing. After creating a selection, you can rename it easily by just double clicking on it. And if you want to add something from a model, you can create easily from easily select from a model by just select in drawing. For example, this, by pressing the control, you can select different types of junctions. So by selecting these junctions, add to selection set, and these are the selections that we have created. So it will add it to this selection. Uh, for example, if you want to select the selection set, you can easily select it from this dialog, from this button. If you want to add some other junction to this selection, you can just select the junction and click on right click on the junction and then add to selection. So it will also add, this junction will also add to this selection criteria. So if you want to select all of these junctions, so you can easily select just by clicking on this button, based on the respective selection set. If you want to select all the junctions in your model, you can select it from here. So it will select all the junctions. Similarly for the pipe, so you can easily select from here as well. You can also select different types of pipes, nodes or junctions from by using the polygon command, by just making a polygon. So the pipe or the junctions which comes under that polygon, so it will be selected as specified. And you can also make this inward selection. So basically I select these and I want to make reverse of that selection, so you can also do that from easily from here as well, and you can clear selection easily from here as well. Other thing Okay, prototypes. Basically, when you start a model, so you want that, for example, if I create a pipe or a junction, it have a default property. So you can do that as well from a prototype as well. So you define a prototype that it should have a 6 meter or 6 inch of dia, or for example, 8 inch of dia. You should have material of a ductile iron or the cast iron or PVC. So you can use these different types of material present in the library of WaterGEM. For example, I want to use PVC. You can easily see that the different types of property regarding to each pipe is showing here. The cutter and will use the Manning's and will use the Hazen-Williams coefficient, the modified Hazen-Williams coefficient. So these are basically predefined in a software. You have just to select a specific material, and these and the properties to these specific material will be assigned automatically. So for example, if you want to create a pipe, and it should have a property by default as a PVC, and it should have a diameter of 8 inch, depends on your choice. So you can easily create that from using prototype. So I want to create a PVC pipe. So if I create a pipe, so for example, I want to create a pipe, it will have default properties of PVC. So you can see here that it have a default die of 8 inch and PVC, and having a Hazen-Williams coefficient of 150. So similarly for the PRV, different type of walls, and for a tank, and for a pump, so you can design a uh, default properties to these different elements of WaterGEM, depending upon your choice. Okay, other thing I want to show you. So here in WaterGEM is a lot of functionality to create reports. In ePanet you can't do this in ePanet. So the WaterGEM is very flexible to do different type of things. You can create a quick graph from here by selecting a pipe. So you can create different type of graph at an easy way. Okay, similarly, you can use the queries for different purposes. You can select that, and you can create it by slot. Okay, for example, if you want to navigate for navigate to specific junction or a pipe, you can create this as well from the navigator. For example, for all pipes, for all junctions. So just by clicking this right arrow and going to network review, there are different properties and as well as the different results. You can also navigate it easily from here. For example, for a junctions, you can easily create it just by clicking on the junction. And for example, if you want to select this junction or move to that specific junction, you can easily go to this specific junction by using a navigator. So there's a lot of functionality, and if you want to go to specific selections, so you can also do that from here as well. So So these are the different functionality in a WaterGEM. Go through it one by one in a detail. If you have find any difficulty, then you can ask me easily. Okay, so I want to show you today the criticality analysis and the automated fire flow analysis. Basically, if you design a water supply network, so you should know about your segments, your pipes, and you should know about the different type of loops in your model. And you know about that, for example, if this pipe, the bursting of this pipe occurs, then how much the your model will be affected and how the demands will be affected. So the criticality analysis in WaterGEM show you that for each segment or for each pipe, if any type of failures occur, then how the remaining system will work and how the demands will vary and how the pressures at each junctions will vary. So based on the criticality analysis, so you to do a criticality analysis, so you have to go to the analysis tab and then click on the criticality. So the dialog will open. Okay, so the before showing criticality analysis, I want to show you that the criticality analysis, the WaterGEM do that by considering a walls in a critical segment, uh, and by also doing it by considering a junctions. For example, if I disable this uh, this function, so it will create a segments based on the node, the pipe connected between two nodes. And if I selected this function, so based on the valves involved in the different localities, which I will install here in a while, that based on that these walls, it will create a different segments, and then based on these segment it will analyze that for a specific segment, if there failures occurs, how the remaining system will affect it. So first of all, I want to uncheck this, and this if you uncheck this, basically these walls are useless. To select these options become useless, because based on the criticality analysis works based on the pipes connected to the nodes. So I want to do for a base scenario, so you can do the criticality analysis for different types of scenarios as well. So I want to check a critical pipes or segments. You can also check a critical walls, that for example, here is there any walls installed in a water supply networks close or open, such like that. You can also find it in the WaterGEM or the criticality analysis. So based on to find the critical pipes or critical segments based on the pipes connected to the nodes, you can easily find it from this by running this scenario. Okay, to run this algorithm, you have to select the whole network, and you can also, I think you can also do it from for specific pipes or network of for specific uh, selection set as well. So I want to do it for a whole network. So by first run, it will just show you the different type of segments involved in your whole water supply network. So it will basically show you the different type of segment involved in a water supply network. By selecting this button, it will highlight each segment by giving color to each segment. Okay, well, So based on the node, the pipe connected to each node. So based on that, the criticality analysis will divide each pipe, and the remaining analysis and the network will be analyzed based on these segments after running this algorithm. So basically, in water supply network, uh, we mostly mm, in water supply network, we basically to analyze the criticality, or to determine the criticality of water supply network, we mostly use a valves. Basically, if the failures occur, uh, for example, if I install here a valve isolation valve, or PRV, or PSV. So if any failures in this pipe occur, so I can easily shut down this pipe by just shut downing the isolation valve, and I can reduce the whole system will be affected because the whole system connected to this pipe. But we can decrease the depletion of water because of the busting of a pipe by just closing the valve in this pipe. So basically, we mostly divide the whole water supply network based on the valve installed in the water supply network. So I want to show you that that the criticality analysis is based on the valves installed in the water supply network. So I will just delete this study, okay, and I want to install some of the valves in the water supply network isolation valve. You can split the pipe by inserting a isolation valve in a pipe, or you can also connect it to the pipe by just referencing to it. So I want to show you that how to reference a pipe by inserting a isolation valve. So it's basically not connected to this valve. You can just connect it by just giving a reference to it. So the type label you should know about. So it's basically the P5. So you can add it to the select is from this pipe. So it's connected. Basically, the wall is basically connected to the this wall. I want to add some other walls as well. Okay, split it. And here I want to add some wall as well. And I will add as well here. Okay. After inserting these walls in a water supply network, okay, I'm going to stop this recording because and I will share another link.